Use vertices of triangle ABC and DEF to show that angle C is congruent to angle F. So first let me draw XY plane. We have unit, and now first point is 2, 2. So 2x and y is 2. So we have point A. B is 4, 3. 2, 3, 4, 3. So will be point B. Has coordinates 4, 3. A has coordinates 2, 2. And C 3, negative 1. So will be approximately here. This is 3, negative 1. Now we have to connect these points and we have triangle ABC. Second triangle DEF, first coordinate of point D is negative 2 and negative 2. So this is our point D, negative 2, negative 2. Next we have point E, negative 4. 4 and negative 3, so we have to go down approximately here. This is point E, negative 4, negative 3, and point F is negative 3, 1. So it's approximately here. F, negative 3, 1. So now we have to connect these points. We have triangle DEF. We have to show that angle C is congruent to angle F. It means we have to show that triangle ABC is congruent to triangle DEF. To do this, we will have to find the sides of our triangles. So we need to find the distance between the 2 points. Let me remind you formula when we have point A, coordinate x1, y1, b, x2, y2. The formula for the distance AB is square root of x2 minus x1 to second power plus y2 minus y1 to second power. So first we have to find the distance between points A, B. So this is equal square root of, we have x2 minus x1, so this is 4 minus 2 to second power plus, and we have y2 minus y1, so it's 3 minus 2 to second power. This is equal, 4 minus 2 is 2, 2 to second power is 4, plus 3 minus 2 is 1, to second power is 1. So this is square root of 5. Next we have B, C. Let's put, so this is equal, square root again. And now the second point is C. So from the second we have to subtract the first. So C is 3 minus B is 4, first coordinate, to second power, plus we have negative 1 minus 3 to second power. So this is equal square root of 3 minus 4 is negative 1 to second power is 1 plus negative and negative, so will be negative 4 to second power is 16. So this is equal square root of 17. And CA is, now the last is A, the first is C. So from A we have to subtract C. So we have 2 minus 3 to second plus 2 minus negative 1 to second power. So this is equal Square root of 2 minus 3 is negative 1 to second power is 1 plus negative and negative give me positive, so will be 2 plus 1 is 3 to second power is 9. So this is equal square root of 10. Next, we have to find the distance between DE, EF and FD points. So first we have DE will be square root of E is the second point, D is first, so we have negative 4 minus negative 2 to second power plus negative 3 minus negative 2 to second power. So this is equal, negative and negative give me positive, negative 4 plus 2 is negative 2 to second power is 4, plus we have negative and negative will be positive, negative 3 plus 2 is negative 1 to second power is 1, so this is square root of 5. Next we have EF, so this is equal square root of F is the second, E is first, so we have negative 3 minus negative 4 to second power plus 1 minus negative 3 to second power. So this is equal square root of negative, negative give me positive, negative 3 plus 4 is 1 to second power is 1 plus negative and negative positive, so 1 plus 3 is 4 to second is 16, so this is square root of 17. We see that AB is equal to DE and BC is equal to EF. So let's check now the FD side. So the first is F, second is D. So we have from D, we have to subtract F coordinates. So we have negative 2 minus negative 3 to second power plus, and we have negative 2 minus 1 to second power. So this is equal square root of negative and negative is positive, so negative 2 plus 1 is 1 to second power is 1 plus negative 3 to second power is 9, so this is equal square root of 10. We got that side AB is equal to DE and BC is equal to EF and CA is equal to FD. It means that AB is congruent to DE and BC is congruent to EF and CA is congruent to FD. So by side congruence postulate, we have that triangle ABC is congruent to triangle DEF. It means that corresponding parts of congruent triangles are congruent. So angle C is congruent to angle F. This is my solution.